right, today we're going to be looking at 4.10. 4.10, we're going to be looking at fitting quadratic models, which means we are going to be using graphing calculators today. If you do not have a graphing calculator, you will need to get one at this time. Okay, so one of our vocabulary terms for today is going to be the best fitting quadratic model. This is the model that is given by performing the quadratic regression on a calculator. Now, there are several different ways that we can look at quadratics, specifically several different forms. As we've learned so far, some of our different forms are things like the vertex form. That is where our quadratic equation is going to be something like a x minus h quantity squared plus k, where k is a vertex, and the line x equals h is our axis of symmetry. We've also looked at the intercept form. Where we have y equals a x minus, I think we did p's and q's, so x minus p, x minus q, where your zeros would occur where x is equal to p or x is equal to q. Your axis of symmetry is going to be the line x equals p plus q over 2. And your vertex is going to be at p plus q over 2 and whatever your function is defined by. So what we're going to be doing is we're going to be looking at graphs, and we are going to be writing quadratic equations for those parabolas, and then we're going to be looking at data and putting that into our calculator. I have one example, and we need to write the quadratic equation for what we see here. Now you'll notice down here I have a vertex. So that means if I look at the vertex form, y equals a x minus h squared plus k, I already have an h and k value to put in. So I've got x minus a negative 2 squared plus a negative 3. So this becomes a x plus 2 squared minus 3. Now, how do I find this a value? Well, I look right here at this point. I'm given the point 0, 5. So if I put 5 in for y and 0 in for x, I should be able to then solve for a. So I get that 5 equals a times 4 minus 3. So that means 8 equals 4a. So a is going to equal 2. So my full equation for this parabola is going to be y equals 2. X plus 2 quantity squared minus 3. So let's try another one here. You'll notice right here we have the intercepts where it crosses the x-axis. So that means we're going to be looking at another form. We're going to be looking at the intercept form. So I've got a, x minus p, x minus q. Well, the p is going to be negative 3. The q is going to be 2. You could flip those, the order doesn't matter there. So I've got a, x plus 3, x minus 2, and that's my y equals. Well, I've got to still find this a value. So I'm going to look at here. I've got 1 point, negative 2, negative 4. So I'm going to put negative 4 in for y. I'm going to put negative 2 in for x. So what I'm going to get here, I've got a times 1 times negative 4 equals negative 4. So that means a has to equal 1. So my full equation for this parabola is x plus 3 x minus 2, and that's going to be an intercept form. Say that I give you that we have two x-intercepts. Those x-intercepts are at -2 and 1, and a single point on the graph is -1, -4. So the graph crosses through that point. If I want to find the equation, what I'm going to do is I'm going to start with the intercept form. Why? Because I'm given intercepts. So I've got x minus p, x minus q times a. I'm going to sub in my intercepts. So I've got x minus a -2, x minus 1 is equal to y. So y equals a, x plus 2, x minus 1. Now I'm going to take this point I'm given. -4 is my y value. My x value is -1. So I'm going to get -4 equals a times 1 times -2. If I divide by -2 on both sides, I'm going to get that a equals 2. So my full final equation is going to be y equals 2, x plus 2, x minus 1. Final answer. All right, let's try this again. So we've got a vertex at 2, 1, point on the graph at 0, 4. There are millions of points. We just picked one. We've got y equals a, x minus h squared plus k. That's our vertex form. I'm choosing that because my vertex will fill most of that information up. So I've got a, x minus 2 squared plus 1. If I plug in my data values, I'm going to have 4 equals a, 0 minus 2 squared plus 1. So I'm going to subtract 1 from both sides. I get 3 equals a. -2 squared is 4. So my a is going to be 3 divided by 4. So my full equation is going to be y equals 3 over 4 x minus 2 squared plus 1. Final answer. You're probably wondering, what if we have 3 points that are not vertices and are not intercepts? So if I have 3 points like -2, -6, 0, 6, which is one of our 2 intercepts but doesn't give us enough information, and 2, 2. If I have 3 points like that, how am I going to solve for the quadratic equation? Well, what I'm going to do is I'm going to think about it. My quadratic equation is going to be y equals a, x squared plus bx plus c. So I'm going to plug each of these points in. So I've got -6 equals a, -2 squared plus b times -2 plus c. So my -6 is going to equal 4a minus 2b plus c. If I plug the next point in, I'm going to get 6 equals a times 0 squared plus b times 0 plus c. So I get that 6 is equal to c. If I look at the next point, I'm going to get that 2 is equal to a times 2 squared plus b times 2 plus c. So I get that 2 is equal to 4a plus 2b plus c. So I have 3 equations and 3 unknowns. Well, luckily I know that 6 is c, so that means I can substitute it in here. So I've got -6 equals 4a minus 2b plus 6. I've got that 2 equals 4a plus 2b plus 6. So if I move that over, I get that negative 4 is 4a plus 2b. If I move it over here, I'm going to get that negative 12 is equal to 4a minus 2b. Now I'm going to flag something here. I've got a plus 2b and a minus 2b, or not 2b. If I add those together, if I take negative 12 equal to 4a minus 2b, and I add that to negative 4 equals 4a plus 2b, my b's are going to cancel. So I'm going to get negative 16 equals 8a. That tells me that a is equal to negative 2. Well, if a is equal to negative 2, then I can pick one of these, substitute my negative 2 in, and solve. So I'm going to have negative 4 equals negative 8 plus 2b. Add 8 over, so I'm going to get 4 equals 2b. So b equals 2. That's going to give me a final quadratic of y equals negative 2x squared plus 2x plus 6. It took using all of our linear skills to create the equations, the unknowns, substitute, and solve, but we got there. So this is your final answer.